Okay, so internet security applications. So the first one we have is Message Authentication Code, MAC, or Financial Institution Message Authentication Standard, FIMAS. So this is basically used to secure messages that are being sent. So it's mainly used in financial institutions to secure payments. So we have a sender and a receiver. So the sender will send a message along with this MAC code, which will be computed with a hashing algorithm and secured and encrypted using a secret key. So this secret key is shared between the sender and the receiver before any data is sent. So then our message is sent, and then the receiver recomputes the MAC. So if the MAC matches the one that was sent, the message is authentic, and then the integrity is checked to ensure that nothing has changed with the data. A secure electronic transaction, or SET, is also used in the financial sector. It's used to provide confidentiality, which prevents unintended people from reading the messages being transferred. So it implements this using encryption techniques. The next one, authentication. It checks if the use of credit cards is done by an authorized user or not using XR509v3 certificates, and it provides message integrity, so it does not allow any modifications to messages with the help of signatures, and they are protected against unauthorized modification using RSA digital signatures. So participants in SET are the customer, the merchant, the customer's financial institution, the merchant's financial institution, and the payment gateway. Okay, so SET's dual signature is generated by the customer. So it takes in the payment information and the order information, which are both then hashed, which becomes the payment information message digest and the order information message digest, which is then appended together. So basically they are combined, and then that's hashed again, and it becomes the payment order message digest, which is then encrypted using the customer's private key, which becomes a dual signature. So now the purchase request generation, so this is going to be received by the merchant. So the payment information, the dual signature, and the order information message digest are encrypted using a symmetric key encryption. So it uses a temporary symmetric key, which is also encrypted using a public key from the bank. So the public key from the bank is sent in a digital envelope, while the rest of the encrypted payment information, dual signature, and order information message digest are sent in this packet along with the customer's certificate, which is then received by the merchant, and it is also passed to the payment gateway after it has been sent to the merchant. So the merchant sends it to the payment gateway. So then the purchase request validation on the merchant side. So we have to recreate two payment order message digest and compare them. So the cardholder certificate as well as the dual signature are decrypted using the customer's private key. I mean public key. Since we use the private key in encryption, we have to use the public key for decryption. So it is decrypted and made into a payment order message digest. And then the payment information message digest and the order information. So we already have the hashed payment information and we have the non-hashed order information. So if we hash the order information, it becomes the order information message digest. And then we append the order information message digest to the payment information message digest. And we hash it, it becomes the payment order message digest, which is then compared to the one decrypted by the customer's public key. So if they match, the request has been valid and the purchase can be completed. Okay, so Mondex and EMV. So Mondex is the predecessor to EMV cards. It was developed in the 1990s, specifically 1990, to act as a cashless form of money. So instead of walking around with money, you would walk around with just this card, such as so basically it's like a debit or credit card. So it's a reloadable prepaid card, which all of the funds are stored on the card and not to any associated or linked account. So the one drawback of this was that there's no way to verify who is using the card. So normally you would enter a PIN when using a credit card or sign a signature when you use the card, but this didn't have any of that. Also, if the card was lost or stolen, you would lose all the funds. So later on, EMV was created. So EMV stands for Europay, MasterCard, and Visa. This is more of a coalition. They define the standards for cards and devices that use and read the integrated circuit or the chip on the card. So this is more secure than magnetic stripe cards, since the technology in the chip and the requirement to enter a unique PIN are far more secure. The reason why the magnetic strip isn't as secure as this is because the magnetic strip can be easily hacked. Okay, so secure sockets layer, SSL, and transport layer security, TLS. So, see, SSL and TLS are the same thing. SSL is the older version, and TLS is the newer version, but SSL is just used everywhere since it's already widely known. So SSL/TLS provides security to data that is transferred between the web browser and server. It encrypts the connection between a web server and a browser and ensures that all the data passed between them remains private and free from attack. So it has 4 protocols: the record protocol, the handshake protocol, the change cipher spec protocol, and the alert protocol, seen here in the SSL protocol stack. So the SSL record protocol provides 2 services to an SSL connection. It provides confidentiality and message integrity. So the application data is divided into fragments and these fragments are compressed, which is optional, and then an encrypted MAC is attached to an encrypted fragment, and then both of these things are encrypted, and then the SSL header is attached or appended to the data. Okay. The handshake protocol, so and this is used to set up a secure connection between the client and the server. So the client first sends a client hello message along with supported cypher suites, and it guesses the key agreement protocol as well as sends the key share for that agreement protocol. So then the server sends a server hello along with a key agreement protocol and the key share if the client guessed correctly. So the reason why the client guesses the key agreement protocol, so in the older version there were 37 key agreement protocols, which would make guessing just not appropriate since just like a 1 in 37 chance. So the new TLS 1.3 has only 5 key agreement protocols. So the chances are much higher to guess correctly, since a client can determine what agreement protocol is going to be used based on the information to be sent. So the server sends the key agreement protocol, the key share, as well as the certificates, and sends a server finished message, and then the client will check the certificate and authenticate it and use the two key shares, so its key share and the one it received from the server, to calculate its own copy of the session key, and then it'll send a client finished message. Okay, so the change cipher protocol. So unless the handshake protocol is completed, the record output will be in pending. So after the handshake protocol, the pending state is converted into current state. So this change cipher protocol basically changes the cipher suite used. So it contains a single message which is 1 byte in length and can only have one value. The alert protocol is used to convey SSL related alerts. So each message in this contains 2 bytes. So status changes include things as error condition, like invalid message received or message cannot be decrypted, as well as things like the connection has been closed. So level alerts can be classified into 2 parts: warning, so these alerts have no impact on the connection between the sender and the receiver, and fatal alerts, which break the connection between the sender and the receiver since some sort of malicious attack was tried on the connection. Okay, so Secure Hypertext Transfer Protocol SHTTP and Hypertext Transfer Protocol Secure HTTPS. So HTTP has been a widely used protocol for data transfer over the web. Hypertext exchanged using HTTP goes as plain text. So basically anyone between the browser and the server can read it relatively easily since it's not encrypted. So this is why we want to secure our web data. So HTTPS combines HTTP with SSL certificates to encrypt data such as personal and financial credentials. So in our scenario, we have a user accessing the site. So the user's device will check the DNS records for IP address to find the web host. The website is then found, and we go to their web server. We then request a secure SSL connection from the website host, and the host responds with valid SSL certificates. So now we have a secure connection which is now established, and data can be transferred. So the transferred data is encrypted. Okay, so Internet Open Trading Protocol, IOTP, is a specification that provides an interoperable framework for internet commerce. It's defined in XML with all of the components, blocks, and messages being XML documents. So it's optimized for the case where the buyer and the merchant do not have prior acquaintance, and a payment system independent. And is payment system independent, sorry. It is able to encapsulate and support payment systems such as SET. Basically, this is a very old and outdated protocol which is not used anymore. Secure Shell is a protocol method for securing remote logins from one computer to another. It provides several options for strong authentication, and it protects the communications security and integrity with strong encryption. So it provides secure access for users and automated processes, interactive and automated file transfers, issuing remote commands, and managing network infrastructure and other critical system components. So SSH is based on a SSH server and an SSH client. So the client initiates the connection by contacting the server, and the server will send back a public key. So then the client and the server will then negotiate the parameters and open a secure channel. So the data is secured with the public key sent by the server. So now the user can log in to the server host operating system. So Secure Shell is basically securing a remote access to another system. Okay, so IPSec, Internet Protocol Security. So it provides security services at the IP layer for other TCP/IP protocols and applications to use. So when two devices want to engage in secure communications, they set up a secure path between themselves that may traverse across many insecure systems. So to accomplish this, they must perform at least these 4 tasks. They must agree on a set of security protocols to use so that each one sends data in a format the other can understand. They must decide on specific encryption algorithm to use. In encoding data, they must exchange keys that are used to decrypt the data that has been cryptographically encoded. And then once these three things are done, each device must use the protocols, methods, and keys previously agreed upon to encode data and send it across the network. So the IPSec protocol suite has two core protocols, which is the IPSec authentication header and the encapsulating security payload, as well as supporting components, the encryption and hashing algorithm, security policies and security associations, and the internet key exchange and key management. So the 5 steps to setting up a secure route using IPSec. So interesting traffic is a term used when talking about IPSec to determine data that needs to be securely transferred. So the devices recognize the traffic to protect. So now the internet key exchange phase 1. So the devices negotiate a key exchange security policy and establish a secure connection. In phase 2, the devices negotiate an IPsec security policy used to protect the data that needs to be protected. Then the data transfer step. So the devices apply security services to traffic and then transmit traffic, and then the IPsec tunnel is terminated, so the connection is broken. And that is the end of internet security applications.